Hello and welcome everybody to today's lecture about protection in electrical power systems. Today I would like to focus with you on protection concepts and network reliability, and we focus especially on network reliability's indicators. So let's start with a typical radial network where one feeder with an installed capacity of 6 MVA, which is the sum of the installed capacity of the transformers, and is protected by one relay only. So let's assume that the first fault in 1 year occurs on feeder number 1 in the front part. That means we lose, after the fault has tripped out, 6 MVA of installed capacity for, say, 2 hours, and this results in minus 12 MVA hours. The next fault, for example, occurs on feeder number 3. Again, the whole feeder is tripped out and we receive minus 12 MVA hours. The feeder number 5 in this network is less lucky than the first ones. So it experienced a first trip, for example, in the front half, and it loses minus 12 MVA hours, and sometimes later a second fault occurs and again 12 MVA hours are lost. So altogether, in this year, this network has lost a sum of 48 megawatt hours. Now let's feed this into the formula for this RCD. This is the magical network reliability parameter, and RCD means average system interruption duration index. So it is the weighted sum of the outages, and in this case it results in 48 divided by 36. Remember, 36 is 6 feeders with 6 MVA per feeder, and then we obtain finally 80 minutes per year as the RCD figure. Now let's see what happens if we subdivide each feeder into 2 sections and we have 2 relays for each feeder. The feeder has the same installed capacity of 6 MVA. And again we have the same sequence of faults. The first fault on feeder number 1, first part, causes again 12 MVA hours lost. But we see the second fault is a little bit better off concerning the lost MVA hours, because here we lose only half of the 6 MVA per feeder, and this results, as you can see, in 6 MVA hours lost. And again, the 5th feeder first fault and 5th feeder second fault results in a total of 36 MVA hours lost. Now, if we feed this to determine the RCD figure for this network, then we obtain a total of 60 minutes of lost supply per year. The last structure I would like to show to you is a ring structure with automatic recloser, recip recloser and a tie circuit breaker. And here we can see what happens in the course of the same year repeated again. So we have fault number 1 on feeder number 1 on the first half, and here we lose, because of the recip principle, only 1 bus bar, and this is 1.5 MVA for 2 hours, and altogether per event it is minus 3 MVA hours. The same happens with the second fault, the same happens with the third fault and with the fourth fault, and altogether we have lost minus 12 MVA hours. Now again, we repeat this process of determining the RCD figure, which is the weighted sum of the outages. And here we arrive finally at a time of 20 minutes per year. Finally, I would like to compare these network reliabilities indices for the 3 types of networks that we have analyzed. So first, let's start with the classic network, 1 protection relay per feeder. We obtained, as you can remember, a weighted outage time of 80 minutes per year. If we introduce a second relay and we install more protection devices, we reduce the outage times and we increase the reliability of the network, of course, by 25% to 60 minutes per year. But if we install this ring type network with automatic reclosers, automatic recip reclosers and a tie breaker, then we result finally with an outage time of 20 minutes, which is only a fourth of the original value. So this shows to us that protection is well in a position to reduce the network outage figures and to increase the network reliability. So this was today's lecture about protection concepts and network reliability. And here we looked into the network reliability indicators and showed that protection increases the network reliability. Thank you very much.